All right, in this video we're going to be talking about how to solve what looks like a very challenging problem. As you can see here, this is the setup of the problem from our text, and so you can then see here's the picture of the representation, and then finally we get to the problem setup. So we're going to work through part A and part B. All right, so in this problem then, what we're really going to be asked to do in part A here is compute the derivative of dl d theta, and then set this derivative equal to 0 to find the critical value of theta. So the loss here is shown in this equation. Now, since we're going to be setting the derivative equal to 0 eventually, this constant in front here is really going to be divided out. So we can ignore this. Meanwhile, I'm going to rewrite this to suggest a more maybe informal or more insightful way of computing this derivative, because it does at first sight look like this could be a very challenging and maybe even formidable opponent, if you will. So the idea here is in this problem that the radii, the r to the fourth, the capital R and the lowercase r, these two radii are going to be constant over the interval where this angle is taking place. And so the only thing that really matters here is, if you look at the geometry, is the angle that is demonstrated here, that angle theta. Okay, so we're going to compute the derivative of theta, or with respect to theta, I should say. So this term here is going to be 0, and this b over r to the fourth and b over r to the fourth here, those are going to be constants with respect to our differentiation. So we're going to factor those out. So the only thing that we're really going to be taking the derivative of is the cotangent and the cosecant here. Okay, so to do that, then we have 0 is equal to d theta. This term is already 0, as I mentioned, so I have the the negative b to the over r to the fourth, and I've written it in front, unfortunately. That should be here as a constant, and so I'm going to be taking really just the derivative of the cotangent plus, and also I'll be more careful here with r, little r to the fourth, d by d theta of cosecant of theta. Okay, so the constants are going to be factored out in front, and so now I have negative b over r to the fourth. The derivative of cotangent of theta with respect to theta is going to be a negative cosecant squared theta, and then differentiating here, we're going to get plus, we're going to have b over little r to the fourth, and the derivative of cosecant theta with respect to theta is going to be a negative cotangent theta cosecant theta. If you don't know where these derivatives are coming from, you can do one of two things. You can either look them up, I guess three things. You can either look them up, or if you know how to convert this into cosine over sine and take the derivative using the product rule or the quotient rule, and then simplifying, you'll get that is equal to cosecant squared theta. Likewise, this is 1 over sine theta, so you can again either use the power rule and the chain rule if you want to do that, or if you just know the derivative of cosecant is cotangent cosecant, with the negative coming from the fact this is 1 over sine. Okay, now you'll notice that these terms both have a cosecant theta in common. There's 2 of them here since there's a square, and there's a cosecant here. So I'm going to factor that common factor out, and since I'm setting this equal to 0, the negatives here also cancel, and so I'm just left with the negative here. So I have a cosecant theta, and then they both have a b and an r to the fourth, but I'm going to leave those in here, as you'll see in a second. So this is cosecant theta, since there's still 2 there, minus, now the cotangent's the only thing that's left over here besides the little r to the fourth and the constant b. Okay, now remember this derivative is set equal to 0, and so either cosecant of theta is equal to 0 or this term is equal to 0. Well, the angle isn't going to be 0, so it can't be this, and so we're going to look at this value here, and so we have 0 is equal to b over r to the fourth cosecant theta minus little b over r to the fourth cotangent theta. Now, all of these terms have a b, and since b is not 0, I can divide out a b here, and like I'm dividing by b here, that's still going to be 0. So this is going to become a 1 and a 1. So, and then if I look at maybe adding this whole term over to the other side, I'm going to have 1 over r to the 4th cosecant theta is equal to 1 over little r to the 4th cotangent theta. Okay. Now this isn't maybe in the most helpful form, so maybe if we write this in terms of a more familiar sines and cosines. Likewise, I'm going to multiply both sides by the little r to the 4th, just so that we have a common ratio. The cosecant, remember, is this is 1 over capital R to the 4th is 1 over sine of theta. Okay, so to kind of move everything with theta on one side and everything with the r onto the other, I'm going to multiply this one by this side by sine of theta, which means I'm going to multiply this side by sine of theta, and likewise I'm going to multiply this side by little r to the 4th. I'm going to multiply this side by little r to the 4th. Okay. All right. So here the r's, the little r's to the 4th are going to cancel. Here the signs are going to reduce, and so I have capital or lowercase r to the 4th divided by capital R to the 4th is equal to, well, I have a sine of theta and a cotangent of theta, but cotangent of theta is the reciprocal of tangent of theta, so you can think of this as cosine of theta over sine of theta. That is cotangent, and then I'm multiplying by the sine of theta. Well, then the sines of thetas are going to reduce out to 1, leaving the cosine of theta. So to solve for the angle theta, then all I need to do is take the arc cosine, or the cosine inverse of both sides. So finally then, r to the 4th divided by capital R is going to be the cosine inverse, or the arc cosine of equal to theta. And since this is the theta that gives us then the critical value of when the derivative is equal to 0, it's a ratio of these two radii raised to the 4th power. This will then be the critical theta that gives us the maximum or minimum value. It gives us the extrema value. We still have to determine the value of the first derivative, if it is in fact what kind of extrema it is. All right, and then yeah. So it turns out that this is approximately 61.1 something degrees, and since the problem was asking us to round to the nearest degree, the critical angle then is at 61 degrees. All right, I hope that was helpful, and I'll see you in the next video.